answering a question.
Okay.
Short, clear answer probably means they get it. Long, rambling one, maybe not so much.
So we're looking for the Goldilocks length.
Mm-hmm.
Not too short, not too long, shows understanding.
Precisely. And it turns out reply length can predict how well the AI will do on other tasks too, like question answering, summarizing text, things like that.
So if they give good, detailed answers in training, they'll do better later on.
That's what they found. Of course, there are always exceptions.
Right. Some people talk a lot but don't say much.
Exactly. But overall, longer replies during training seem to correlate with better performance later.
So it's another way to evaluate these models to see what they're really capable of.
Right. It's not just about the final answer, but the thinking behind it.
And the paper doesn't just observe this. It actually suggests ways to use reply length to make training better.
Yeah. Two methods, actually. One is called SRDPO.
Catchy name. What's that?
It stands for Score Regularized Direct Preference Optimization. Now, DPO. That's where you have another AI, like a coach, judging the main AI's answers.
Okay, so there's a coach AI involved.
Right. SRDPO basically tells the coach, hey, don't give high scores to answers that are too short or too long.
So make the AI find that balance. Don't just talk a lot, but don't be too brief either.
Exactly. And this worked really well. The model started giving much better answers, the right length, informative, but not rambling.
So you can actually use these constraints to guide the AI towards the kind of output you want.
Precisely. Now, the other method, SRIPO, that stands for Score Regularized Imitation Policy Optimization.
Okay, that's a mouthful.
IPO is where the AI learns by copying a teacher model. Could be another better AI, or even examples written by humans.
Like an apprentice learning from the master.
Yeah. SARS IPO basically tells the student AI, hey, pay attention to how long the teacher's answers are. Don't stray too far from that.
So learn the style, the level of detail, all that.
Exactly. And SAR IPO helped too, especially for tasks where the way you write is important, like persuasive essays, marketing stuff.
It's amazing how something as simple as the length of a reply can be used to train these AIs.
It is. Sometimes the smallest details reveal the most. But there's a problem researchers have run into.
What's that?
Sometimes when they fine-tune these LLMs on lots of data, even harmless stuff, it makes them worse at certain things.
Really? Like what?
Especially things related to safety, ethics.
But I thought more data was always better.
You'd think so. But it turns out focusing too much on being helpful, being polite, it can make the AI less good at spotting bad stuff.
Interesting. Like a student who's so eager to please, they forget to think for themselves.
Exactly. So how do we make sure these models are both helpful and safe? One paper tackles this head on.
What do they suggest?
Different prompting strategies and ways of adding to the training data. Like one strategy is paraphrasing.
Okay.
Say you have an instruction, write a story about a knight. You reword that in different ways. Tell a tale of a warrior. Describe a hero's adventures.
So the same basic idea, but different angles.
Right. This gives the AI a broader understanding of the task, makes it less likely to have that performance drop.
Like exposing a student to different teaching styles.
Exactly. Another technique, data augmentation with safe examples. This is adding instructions that specifically say, don't write anything bad or biased.
Ethics class for AI.
Right. Training on both good examples and these safety rules helps find that balance. They even talk about automating this using another LLM to come up with safe instructions.
So AI creating safety guidelines for other AI.
Yep. And using these strategies, especially those safe examples, really helped. The models stayed ethical, but still did well at their other tasks.
It's good to see researchers focusing on this. We can't just assume AI will be ethical automatically. We have to guide it there.
Couldn't agree more. Now, another paper uses this idea of instruction following difficulty, or IFD.
IFD,
Basically, you use the AI to tell you which instructions are hardest for it.
like asking what questions stumped you.
Exactly. And the instructions it thought were difficult, those were often the most helpful for training.
It's like the AI is raising its hand in class saying, I need help with this one.
That's a great way to think about it. Focusing on those hard instructions makes training more efficient. But they didn't stop there.
What else did they do?
They also came up with reversed IFD, or RIFD.
Okay, now that sounds confusing.
It's kind of the opposite. Instead of measuring how hard it is for the AI to follow an instruction,
Right.
it measures how much the AI's answer helps you guess the original instruction.
So how clear the answer is, basically.
Yep. If the answer makes it really obvious what the question was, that means the AI probably understood it well. Those are the good instructions to learn from.
It's like the AI has to show its work. so to speak, not just give a random answer.
Exactly. So by using IFD and RIFD together, you get training data that's both challenging and informative.
A good test for the AI students.
Yeah.
And speaking of good answers, there's a paper about making AI-generated text less robotic, more natural,
Ah, yes, the fluency problem.
making it sound more like a human wrote it,
Right. A lot of AI writing is accurate, but it's kind of stiff.
like a textbook, not a novel.
Exactly. So this research introduces depth pruning of LLMs.
Depth pruning sounds intense. What is that?
It's actually removing parts of the model.
Really? Like deleting parts of its brain?
It sounds weird, but research shows that removing certain layers, especially towards the end of the processing, it can actually make the writing more fluent.
Like trimming a tree so it grows better.
Exactly. And they use different methods to choose which layers to prune. One uses something called Shapley value.
Never heard of that.
It's from game theory.
Okay. So how does that apply to AI?
It's a way to figure out how much each part of the model contributes to the final output. You identify the star players, the parts that are really important for fluency.
Optimize the team, get rid of the dead weight.
Exactly. And pruning those less important layers, it often worked. The AI's writing got smoother without losing its accuracy.
It's amazing how ideas from other fields can help with AI.
It is. Thinking outside the box is key. Now, before we finish up,
Yeah.
let's talk about a really cool application of LLMs.writing code.
Wait, AI that can write computer programs.
Yep. As these models get better, people are trying them on all sorts of tasks. Coding is a big one.
So they're learning the language of computers.
Exactly. This research paper introduces Big Code Bench. It's a way to measure how well LLMs can write code.
Like a coding contest for AI.
You got it. It tests them on lots of stuff, easy and hard coding challenges. They tested a bunch of LLMs, including some specifically made for coding.
Like the AI coding whiz kids.
Exactly. And the results were really good. These coding-focused LLMs wrote high-quality working code in several different programming languages.
Wow, that's impressive. So could AI help human programmers? Or even write entire programs on its own someday?
It's definitely possible, but, with great power comes great responsibility, right? We need to be careful about the ethics here.
Right, we don't want AI writing code that does bad things.
Exactly. It all comes back to making sure this technology is used for good, right? It's like giving the AI tutor some extra rules. Don't just reward long answers, make sure they're good quality too.
And how well did that work?
Really well. The model's answers got much better, informative, but also the right length, not too rambling.
So it's about setting those clear expectations for the AI.
Exactly. Now, the second method, SRIPO, that stands for Score Regularized Imitation Policy Optimization.
Okay, another mouthful.
It's based on IPO, where the AI learns by copying a teacher, which could be a more advanced AI or even stuff written by humans.
Like an apprentice learning from a master craftsman.
Exactly, and CRIPO adds a similar rule. It basically tells the AI, hey, look at how long the teacher's answers are. Don't go way off from that.
So imitate the style, the level of detail.
Exactly. And CRIPO was helpful too, especially for tasks where the way you write matters, like persuasive essays or marketing copy.
It's amazing how much you can do with just the length of a reply.
Yeah, sometimes the simplest things can be really powerful, but researchers have hit a snag sometimes.
Oh, what's that?
Sometimes when they fine-tune these models, even with good data, it can actually make them worse at some things.
Really? I thought more data was always better. What kind of things get worse?
Especially things related to safety, ethics, that kind of thing.
So being too polite, too focused on being helpful,
Yeah.
it can backfire.
Yeah, it's like, imagine a student who's so worried about pleasing the teacher that they forget to think critically.
They don't want to rock the boat, even when they should.
Right. So how do you make sure these models are both helpful and safe? There's a paper that looks into this.
Okay, what do they suggest?
They try different ways of prompting the AI and also different ways of adding to the training data. One strategy is paraphrasing.
I know what that means, at least.
Imagine you tell the AI, write a story about a knight. You can say that in lots of different ways, right? Tell a tale of a warrior. Describe a hero's adventures.
So, same idea, but different wording.
Exactly. And by training on these different versions, it gives the AI a broader understanding.
It's not just memorizing one specific way to say things.
Right. They also use data augmentation with safe examples. This is adding instructions that specifically tell the AI, don't say anything harmful or biased.
Ethics lessons for the AI.
Exactly. So you train it on both good examples and these explicit safety rules. They even talk about using another AI to come up with these safe instructions automatically.
Whoa, so AI generating ethical guidelines for other AI.
Yeah, it's pretty meta.
Well,
And using these strategies, especially those safe examples, it really worked. The models stayed ethical but still did well at other things.
it's good to see people thinking about these ethical issues. It can't just be an afterthought.
Absolutely. Now, there's another paper that looks at something called instruction following difficulty, IFD for short.
IFD, okay.
Basically, it uses the AI itself to tell us which instructions are the hardest for it.
So we're asking the AI, what are you struggling with?
Exactly. And the things the AI found difficult, those turned out to be the most helpful for training.
It's like it's pointing out its weak spots so we can work on them.
That's it. Focusing on those hard instructions makes the learning process more efficient. But they took it a step further.
How so?
They also came up with reversed IFD, RIFD.
Reversed. I'm not sure I follow.
Instead of how hard the instruction is to follow, it looks at how much the AI's answer helps you guess what the original instruction was.
Okay, so if the answer is clear and relevant, that's good.
Exactly. It means the AI understood the task. And those are the best instructions to use for training. It's about finding instructions where the AI can't just give a random answer. It has to really demonstrate understanding.
It's like making sure the AI shows its work, not just the final answer.
Exactly. By combining IFD and RIFD, you get training data that's both challenging and informative. But then there's the issue of making AI writing sound more human.
Yeah, that's a big one. A lot of AI writing is just kind of awkward.
Right. It's accurate, but not very fluent. There's a paper that looks at this. They use a technique called depth pruning of LLMs.
Depth pruning. What does that mean?
It actually involves removing parts of the model.
Wait, seriously? Deleting parts of the AI's brain?
It sounds strange, but research has shown that getting rid of certain layers, especially towards the end of the processing, it can make the writing smoother.
Less robotic.
Right. And they have different methods for choosing which layers to prune. One is based on Shapley value, which comes from game theory.
Game theory, that's for, like, figuring out the best strategy in a game, right?
It is, but it can also be used to analyze how each part of a system contributes to the overall outcome. So they use it to see which layers are most important for making the writing fluent.
And then they get rid of the ones that aren't pulling their weight.
Exactly. And this often worked really well. The AI's writing became more natural and engaging without losing accuracy.
It's amazing how ideas from totally different fields can be applied to AI. You never know where the next breakthrough will come from.
Exactly. But before we wrap up, there's one more paper I want to touch on. It explores using LLMs to actually write computer code.
AI that can program. That sounds both awesome and kind of scary at the same time.
It is pretty amazing. As these models get better, we're seeing them used for all sorts of new things. Coding is a big one.
It's like they're learning to speak the language of computers.
Exactly. And this paper introduces Big Code Bench. It's basically a way to measure how well LLMs can code.
So it's like a standardized test for AI programmers.
You got it. It has all sorts of coding challenges, from simple to really hard. And they tested several different LLMs on it, including some that were specifically designed for coding.
Like the star students of the coding world.
Exactly, and the results were really impressive. The best models could actually write high-quality functional code in multiple programming languages.
Wow. Could you imagine AI helping human programmers? Or even writing entire programs all on its own someday?
It's definitely within the realm of possibility, but with that kind of power, we have to think about the ethical implications very carefully.
Right. AI writing code that could be harmful or biased.
Right.
That's a scary thought.
It is. We have to make sure this technology is used responsibly.
Well, this has been a fascinating deep dive. We've covered a lot of ground, from the basics of CLMs to some really cutting-edge research on how to train and evaluate them.
It's amazing to see the progress that's being made. It feels like we're just scratching the surface of what's possible with these models.
And it's inspiring to see how this research is not just about advancing AI, but also about promoting inclusivity and understanding across cultures.
Absolutely. As we move forward, we have to remember that AI is a tool. And like any tool, it can be used for good or bad. The choices we make now will shape the future of this technology.
That's a powerful message to end on. Thanks for joining us for this deep dive into the world of CLMs. We hope you've learned something new and are as excited as we are about the possibilities of this field.